This test was conducted according to your local standard. Click Focal Law. Click New Law. Enter the name of the focal law that you can recognize. Here we input the probe name we use. Use only one probe. The detection interface don't need to change. Click Next. Enter the probe wedge settings. Click Probe and then enter Click to select probe. Select according to the actual probe you are using. In this case, we use a 30 probe. Select this probe and click OK. Here pops up a window of matching wedge SA326OS37. Click OK to select it. Click next to Wedge Interface. The probe and wedge parameters have been input automatically. Click Next to enter to the channel. All 32 elements are used. No need to change. Click Next. In Workpiece Settings, the workpiece parameters according to the actual workpiece being inspected. In this example, the workpiece type select, V-shaped, workpiece thickness T is 20 mm and weld width is 24 as measured. Use groove angle to adjust weld width. Reinforcement, root gap, blunt edge height, no need to change. Click Next to enter the Scan Settings interface. Adjust the start angle and stop angle to appropriate range 37-72. Focusing type is depth and set focusing distance to twice of the plate thickness as 40 mm. After setting the angle and focusing distance, you need to change the probe front distance. Increase the front distance so that the intersection of the secondary wave and the upper surface of the workpiece covers the weld and the 5 mm heat affected zone. After all settings are completed, click Save and Exit. Insert the probe on the right side of the instrument, the end with cable facing upward. Insert the 2 pins of the probe into holes on the instrument right side and tighten the screws on probe. Click Detection button in the main interface. Choose the name of focus law you just set and click OK to enter the detection function. Click the gear-shaped menu button in the upper left corner of the screen. Click the calibration and click TCG to enter TCG making interface. At least 3 holes must be taken. Here, we use 10 mm, 30 mm, and 50 mm for 20 mm thick plate. The probe is coupled with oil to detect the 10 mm hole. Adjust gate start, gate width to lock the 10 mm SDH and adjust gain value. Move the probe back and forth on the test block for 3 to 5 times to ensure highest reflection signal at all angles of the sector scan are recorded for the 10 mm SDH. The yellow line represents the highest wave at current angle, and the blue envelope is the integration of the highest peak values at each angle. Click the calibration when blue envelope remains unchanged to record the current peak value. Click OK to complete the first sampling point. After taking the first point, we verify it by move the probe back and forth and check whether the peaks of 10 mm SDH are within the 2 yellow lines. Calibration successful. Click Next point to take the second point. Adjust gain. Start to lock the 30 mm hole and adjust range to appropriate value and press shuttle to confirm. Move the probe back and forth on the test block at a constant speed and parallel to the test block edge as video shows. Find the highest peak values at each angle when the blue envelope remains unchanged. Click Calibration to record current peak value and then click OK to complete the second sampling point. Verify as the same as the first point. Move the probe back and forth on the test block to check whether the peaks of the calibrated 30 mm SDH are roughly within the 2 yellow lines. 75% to 85% amplitude after compensation at all angles. If calibration is successful, click Next Point to take the third point. Put the probe on test block. Adjust gain, start, and gate width to lock the 50 mm hole. Adjust the range to appropriate value to cover each angle as much as possible. Adjust the gain value. Move the probe back and forth on the test block to find the highest peak value of 50 mm SDH at each angle from 37 to 72. When the yellow line can no longer push up the blue envelope, and the blue envelope remains unchanged, click the calibration to record current peak value and then click OK to complete the third sampling point. Vary the calibration effect by moving the probe back and forth on the test block to check whether the peaks of the calibrated 50 mm SDH are roughly within the two yellow lines, 75% to 85% amplitude after compensation at all angles. It's roughly on the two yellow lines. Click Curve Compensation. Set the evaluation value, quantitative value, and rejection value to -18, -12, and -4 decibels. Check the box of surface compensation. Input 4 in compensation gain. Click Confirm and then Accept. Return to previous interface. Click Gain and adjust the green line evaluation value to 20% amplitude of the full screen. Verify the TCG curve effect by selecting any hole. Adjust the ref, beam, in basic parameter, and gate start. Gate width, in gate interface, to lock the hole and find its highest wave. Check the dB value, whether can reach 216 decibels. Absolute value, of quantitative value plus compensation value. Click Menu Function button and click Calibration to encoder calibration. Insert the encoder cable to encoder interface by red point to red point. Measure a distance. Here we use 270 mm as of example. Enter 270 into actual distance. Place the encoder properly. Click Reset and then click Start before pulling the wire of the encoder. The starting and ending points use the same reference point. After pulling the wire, click Stop and then click Calibrate on Instrument. Then you can slowly put the encoder line back. You can also test whether the encoder is accurate by click Reset and test again. Check reader. The error in test distance is within 1%. Click Save and then input the name of the encoder as you want. An image acquisition interface. You can change the default time mode to encoder 1 and choose the calibrated encoder name you just set. Click Basic on Menu function and change the range N to suitable range 120 mm before scan. Press the shuttle. Click Menu Function button on upper left corner and click View Control. Change the view to a +S+C and press the shuttle button. Remember the probe front value and measure the distance from the center of the weld to the front edge of the probe as the probe front value. We can use magnetic strip as auxiliary tool. Adjust the scan direct from forward to reverse because there is a handle at the 0-point end that blocks the placement of encoder. Click Start Acquisition to enter the acquisition interface. Because it is reverse direction, the encoder line should be pulled to the end, furthest from 0-point before start acquisition, and slowly back the probe together with encoder line to 0-point. When the probe reaches the encoder, the scanning is finished. The end with steel stamp of plate number is side A. The other half part is side B. Click Save to save the scan map and input the file name. Here, we usually input the plate number and the side you detect so that you can recognize. Click Confirm. Here will pop up a window, shows the file size and data lose rate. Click OK. Then we need to prepare to detect the other side of the plate, side B. Put the encoder and magnetic strip to side B. Check the probe front distance at side B. Ensure it's accurate. Click Start Acquisition to perform the scan of side B. Ensure no broken line appears as black line in the C-scan. You can also use the irrelevant display such as weld reinforcement and weld toe signal as a reference. Click Save to save this scan map and input the name. Click the upper right corner button, Exit Detection, and Save Parameters, back to Main Interface. Click File Management. Insert USB into Instrument USB Interface in Data File. Check the scan map and click Export to export them into your USB. Data analysis can be done on computer data analysis software. This is the entire detection process for flat plate welds.